Welcome to Science and Engineering World, where we use the principles of mathematics and science to think engineering, act engineering, and practice engineering. In this fluid mechanics presentation, we want to look at a simple scenario to be able to demonstrate the property density. And this time we want to look at a peanut butter. Peanut butter. Oh, my name is Olutola Fakehinde. Peanut butter. Is it a fluid or a solid? Well, that's not our topic here. We've done a short video clip which I put a link up and then in the comment section below. Today is a different topic, but before we go further, I will encourage us to please subscribe to this channel and at the same time share the link so that the video can move further to the other part of the world. Thank you for doing that. Today we are looking at the density of peanut butter. What is the density of peanut butter? This scenario here is that a peanut butter fills a cylindrical container of diameter 9.5 cm and height of 14 cm. It also weighs 12 Newton. So we want to look at the specific weight, the specific mass, the specific volume, and the specific gravity of this peanut butter. In evaluating this scenario, let us take some assumptions. The first one, we look at this container that it is not regular, it's not uniform. So we have to take the first assumption that the diameter is uniform throughout the length of the container. And that is why I put this shaded part on it. So we're considering that the diameter is uniform. The second one is that the weight of the container is neglected. The third one is that the peanut butter is assumed to be homogeneous. Homogeneous in the sense that the properties of the peanut butter is uniform throughout the volume of the container. In solving this problem, let us list the data provided, and the first one that is given here is the diameter. So we have diameter given as 9.5 cm. So diameter D equals to 9.5 cm. It is always good practice to have our unit dimension in meters, and we have 100 cm equals to 1 meter. So in this case, we divide 9.5 by 100 to give us 0.095 meters. That's the diameter. Again, we are given the height of the diameter of the container as 14 cm. So we have the height of the container, make it h, is equal to 14 cm. Again, converting to meter, we have it as 0.14 meters. The last one given is the weight, which is given in Newton, and so we can have weight W. Let's use W for weight. We have here W equals to 12 newtons. Now 12 newtons is a standard form we can use to calculate easily. We need to find the volume of the container. So we say that volume with a capital V is equal to area of the base, which is circular, will give us pi d squared over 4 times the height will give us the volume times h. So we can now say here that the volume equals to pi times 0.095 squared over 4 times 0.14, and this will give us a meter cubed. So if we put all this into a calculator, we are going to get 0. Okay, let's put it in standard form. It's going to give us 9.923 times 10 to the power minus 4 meter cube. So this is the volume of the container. With the volume and the weight of the peanut butter known, we can now find its number one, specific weight, and in a video which I made about the properties of fluid, particularly density, I put the link above. We have specific weights with the symbol gamma. That's the symbol gamma. And specific weight is given as that's gamma is given as weight of the substance over its volume. So this gives us the weight we have as 12 newton, and then the volume we have as 9.9323 times 10 to the power minus 4. And by the time we put all of this into our calculator, we have gamma equal to 12,093 0.12, and the unit of this is Newton per meter cube. Newton per meter cube. So that is the specific weight of the peanut butter. So it can be just 12,093 Newton per meter cube. The second one we want to find is specific mass. Specific mass. Specific mass is also known as mass density. Mass density, which we have in that same video, which is rho, symbol rho. Rho is given as mass over volume. We don't know mass, we don't know density, we know volume. So we need to rewrite this and multiply this by 1. That will give us mass over volume times 1. The 1 here will be G over G. Now, because we want to have here that mg, that's the mass, times g here is the weight over the volume. So weight over volume is what we have in specific weight. So that gives us gamma over g. Gamma over g. Good. So we can now say that density is equal to the specific weight that we have obtained here, which is 12,093.12 over g. And g is always given, that's acceleration due to gravity, is always given as 9.81. 9.81. So that is a universally accepted value. Universally accepted value. That's 9.81. 9.81. So putting all of this into our calculator, we now have rho, that's the density of peanut butter, is equal to 1,232.73, and the unit is kilogram per volume, that is kilogram per meter cube. So that is this is the unit of density, and the value for the density of peanut butter is 1,232 kilogram per meter cube. The third one we have to find is specific volume, and specific volume in that video we put as a small v, a small v, a specific volume. So we said that small v, that specific volume, is equal to inverse of density, 1 over density, which is the same thing as density to power minus 1, rho to power minus 1. So in this case, we can now say that specific volume is 1 over 1,232.73. So specific volume of peanut butter is equal to 8. Let's put in all of this into a calculator. That's 8.112 times 10 to power minus 4. And the unit is meter cube because it's the inverse of density, meter cubed per kilogram. So that's specific volume of peanut butter. The fourth one we have to find is specific gravity. In that video as well, so that specific gravity is as a symbol of S, and like I said, it can be SG. Yeah, specific gravity we said is the density of the substance, that's rho of peanut butter, rho of butter over rho of water, because water is the standard liquid for liquid fluid, and this gives us density of the substance of peanut butter is 1232.73 over the density of water is always given as 1000 kilogram per meter cube. So that is 1000, that's over 1000 for specific, for the density of water. So specific gravity of peanut butter is equal to 1.232, and like we said, because it's density over density, it has no unit or is dimensionless. So specific gravity of peanut butter is 1.232. Specific density of water itself will be 1, because it's going to be density of water by density of water, that's going to be 1. From here we can see that the peanut butter is slightly heavier than water. Yeah, if you enjoy what we are doing on this channel, please give it a thumb up, share with others so that they can also enjoy the same thing we are enjoying. At the same time, make comments so that we know if you need other topics or anything you want us to discuss. Keep subscribing to this channel. Subscribe so that YouTube can keep promoting the channel. And like I always say, think engineering, act engineering, and practice engineering. And until the next time we meet, keep studying.